Okay. So, good evening, student. How are you? I hope you are doing good. So, it's quite a lot time that we have spent. Okay. So, long time no see, you know. Um, so, how are you guys? Firstly, you tell me, then I'll tell you. How are you, JNV Yanam student and JNV Ramnagar student? How are you guys? Have you enjoyed the time? No classes, no disturbance. uh, Firstly, let me start with JNV Yanam student. How are you guys? All okay with the health, mindset, and all? Okay. So I think just a second. So today, the topic that we have selected is rectilinear motion. So it is not going to be a full-fledged class, okay? Because I think you have covered this rectilinear motion in your regular classes of your school. So here, and this is there is not too much in this chapter to deal with the conceptual manner, okay? The numerical one or the methods to solve the problem, that is very important. Got it? Now, so we are going to do a crash analysis of this chapter, rectilinear motion. We have selected some topic. We are going through them one by one and try to complete this topic by this Friday, means day after today. Got it? So without wasting so much of time, let's just get started with it. So are you ready, guys? So this is the agenda of today, or today's target, I will say. Okay, got it. Thank you. So this is today's target. So firstly, we will describe what a motion is and what its type. Okay. Then we will discuss what is distance and displacement that we all talk about. This is the first question of every physics teacher. What is the difference between distance and displacement and all the things? Then same with the speed and velocity, same with the instantaneous speed and instantaneous velocity. That instantaneous term I have mentioned for both speed and velocity. Same for the in the preceding one, the average speed and velocity. Then we are going to deal with that also. And in average speed and velocity, we are going to see some cases also. Okay, that is very important for the point of view of exam and point of view of numerical solving. Then we will deal with the acceleration. Okay, what is the acceleration is? How does it affect the motion? Then after that, we're dealing with the equation of motion. Okay, so in equation of motion, we are not going to derive them one by one. Okay, the derivation is not needed yet. But if you found out that you are not able to, or you are getting you want to have some conceptual clarity on this, that how to derive it, you will tell me at that point of time. Okay, I will tell you how to do the derivation and how to derive these equation of motion. Okay, after that we will deal with the general equation of motion. With the help of them also, you can derive this equation of motion. Okay, so this is it all about that we are going to discuss today. And this is not too much, although it is seems to be, but it is not too much. Okay. We will spend the time one by one on these topics and try to describe them. Okay. And try to understand them. Now, firstly, we will deal with what is motion and its type. Okay. So firstly, if I describe you, if I ask you that what is a motion, so generally what do we attach? That anything which is moving is we attach with the motion. No, this is not the old truth you are get to know, or you have known about it. Okay. Now, so motion is nothing but, if anything means anything, person, object, system. If anything change its position with respect to time, that thing is to be in a state of motion. So motion is not a thing, it's a state that we will achieve. It's a state. Like matter has three state: solid, liquid, and gas. As we rise up the temperature, solid converted into liquid, then liquid converted into gas. So these all are the states, and they have various function according to that state. Okay. In the same way, motion is also a state that a body or a system achieve. And how do we achieve that state? By change of position with respect to time. Got it? So this is all about the motion. Motion is a state, and how to achieve this state? Change of position with respect to time. Okay. Suppose this is my hand with the pen. It is here at this point of time. After some time, I have changed the position. So you can say that my hand is in motion. But if it is not changing its position with respect to time, then what that state could be? That state is termed as what? Rest. So rest is also a state in which no change in position. No change in position with respect to time. Got it? Now, if I ask you one question, that you are standing on a road and there is a very fast moving car traveling on that road. So that car in motion or in rest? Tell me, it's a very simple one. Okay. I'll expect an answer from each and everyone. If a car is moving on a road and you are looking at that car, then that car is in rest or in motion. If you are standing on the ground, what it should be? For rest, you should type A, or for motion, you should type B. Okay. Tell me very fast. This is for rest and this is for motion. Come on, guys. When you answering this, in the meantime, I'll write next topic, that is, okay. Just a second, I'll change the color of the pen. Okay. Very good. The comment box is full of B. So you are right, absolutely, because that car is changing its position with respect to time. So you can say that that particular car is in motion. You're absolutely correct. JNV Ramnagar student and JNV Yanam student. Very great to hear. Now, how do we decide that this car is changing its position? How do we decide? So we have a time watch. We will get the time at particular second or particular hour. This car is at this position. After some minute or after some second, it has changed its position. But what if you are also changing the position with respect to time? Okay. So which means that this all phenomena, to describe anything, that it could be in motion or rest, it depends on the observer. So we can say this rest and motion state depends on observer. And observer is who? Observer is us. We are the observer. We are observing that object or that particular car or whatever the object is. We are the observer. Okay. So it is very important to fix the observer. Okay. For that, we have frame of reference. Got it? This frame of reference depends to whom? This frame of reference depends to the observer. And who is the observer? Observer is us. That is observing the motion. That is describing something, that this car is in motion or this particular car or truck is in rest. Who is describing that? Observer. So for observer, we have decided the frame of reference. Got it? Now, in frame of reference, we have two types of frame of reference. First is the inertial frame. Just a second. Inertial frame. And second one is the non-inertial frame. Non-inertial frame. Are we going too fast? Anyone? Any kind of doubt you are having? Are we doing very fast? I don't think so. If you think that I'm going too fast, just let me know in the comment box, okay? So frame of reference depends to whom? Frame of reference depends to observer. Got it? And we will try to make this session very interactive so that you will not get bored. I will also not get bored. Got it? Now, we have talked about the motion. Motion is that if anything is changing its position with respect to time, that particular thing is in a state of motion. If it is not changing the position, then it is in rest. And who is deciding that? The observer, because observer is that person which is observing the motion. Got it? So for the help of observer, we need to fix it, fix the observer. And for that, we have two types of frame of reference, which is first is inertial frame. Matlab, observer can stand on the inertial frame and observer can be in the form of this non-inertial frame. Okay? Now, what is an inertial frame? So you will get to know. I will just brief it here that inertial frame, if, let me change the color here. If velocity, I will describe what is velocity and what is speed. I also know that you know about this, but if velocity of observer is 0 or constant, then that particular frame is inertial frame. But if it is varying, if velocity is not constant and observer is standing in that particular frame, which has a non-zero, non-variable velocity, sorry, non-zero and variable velocity, then we said that that frame is inertial frame. I will take real life example of that. Suppose this is the road that we have. On this particular track, we have a car. Very old fashioned car is this. Moving in this direction. This is ground, you can say. This is the ground. This is grass. You are here standing, enjoying your cup of tea. Okay. You are observing this car. Let's say this is moving with a 10 meter per second speed. To make it more relativistic, we will make it 100 kilometer per hour. Now you can relate it with more. Okay. So this car is in what? Motion or rest? It's in motion because it is changing with position with respect to time. Okay. For each and every second, this car will shift its position because it is moving in this way. Got it? So this car is in motion with respect to this observer. Now, here's a twist. Let's say we have another car. Now you have also bought a car and you are standing in that car also. This car is also moving with a speed of 100 kilometer per second per hour. Same speed. Now tell me, and you are sitting inside that car, and you are observing this car B, and you are in car A. Now, does this car B in motion with respect to you, and you are also traveling with a speed of 100 kilometer per hour, and this car that you are observing is also have the same speed. So tell me, this car is in motion or rest? Tell me, each and everyone. Come on, guys. The car that you need to observe is also moving in 100 kilometer per hour. That car in which you are present is also moving with 100 kilometer per hour. So this car seems to be in motion or rest. That's the simple question I'm asking you. Okay. You are sitting inside the car, and there is another car which is moving with the same speed. Okay. So JNV NM student is saying that rest. Yes, answer is correct. Okay. Then what is the explanation? Explanation is that if both the car has same speed, which means they are changing their position in a same manner. So each and every step, they are at the same level. Okay. That usually happen to us when we are taking a motorbike riding or in a car, and we just cross anything, and due to some reason we are not able to cross that particular motorbike or particular car. So it seems to be that we are moving together. Okay. So that particular person is not changing the position with respect to time and with respect to us. Same happen here. This car A is moving with 100 kilometer per hour. This car B is also moving with 100 kilometer per hour. So in per hour, they are covering 100 kilometer, which means if both the car here at 0 kilometer, so at 1 hour later, they are at 100 kilometer facing each other each and every time. Although they got angry, why you are following me? Why are you not changing your speed and all? But that is not our matter. They will sort it out. Our matter is that the position of car B with respect to car A is not changing. So that is why this particular car seems to be in rest. Got it? So this is the concept of it. Now, if you are in the car, any one of the car you can choose. Both the car are same model wise and speed wise. So if you are in car B and you are observing this particular observer which is standing on the ground, this one, if you are observing this person, now tell me, you are sitting inside a car which is moving with some velocity, some speed, and that is 100 kilometer per hour. Now you look at that person, you lay down your window, you take a look of that person. That person is changing its position with respect to time or not? Tell me. With respect to you, the position of that particular man or woman change, that is standing on the ground right here, which is standing here. It changed, na? Because when your car is here, you are you are in rest with respect to your car, because you are not moving anywhere. You are sitting on the driving side or conductor side. You are there for the total journey. Okay. So you are in rest with respect to your car. But when you observe outside, the trees are moving. Okay. It seems that they are chasing you. The man and woman, children's that are standing on the road waiting for the bus and trains, they are also seems to be keep moving in the backward direction. Okay. So it all the matter of from where you are observing. Okay. Got it? So if a man standing on the ground see a vehicle moving with some speed, That person say that this is in motion because it is changing with respect to time, changing its position with respect to time. But if a person sitting inside a car or a bus or a bike and it start observing the nearby of it, then he or she will say that this particular tree, this particular person is changing their position with respect to time because I am here, I am on the bike for all the time. I'm not changing my position with respect to time. That particular person is. So he or she is in motion. That particular tree is in motion. Okay. So it's the relativeness in between them. You change the frame of reference from where you are observing, you change the scenario of rest and motion. I hope you are get it that I have told you. Anyone, any kind of doubt now in rest and motion? How to decide that something is in rest or motion? Anyone? If you have any kind of doubt, you can ask all the time. Okay, anytime you can ask. Got it? Now, if I talk about there are two types of motion that we are going to discuss. The first one is uniform motion. Second one is non-uniform motion. Just a second. I'll erase this all. Yeah. So the motion that we have is first one is uniform motion and the second one is what? Non-uniform motion. Now we will move on to the next slide when we complete those topics that is able to explain what a uniform motion is, what a non-uniform motion is. We will get back to this slide and update this. Got it? Now, firstly, we will tell about distance and displacement. So suppose you are standing at this point A, you have traveled a distance like this. There are so much of cliffs in the path you have followed and you have reached at this position B. This is you here and this is also you. So you have been tired at this position. You have seen it. Okay. So let's say what is distance is? Distance is the actual path traveled, actual path traveled. No matter how much turns you have take, no matter you have returned to your home and then you are going back to that position, no matter whatever the path you have covered in your journey, this will be counted as distance. Got it? So distance is nothing but the actual path traveled. Suppose you have started your journey from A, you go to B, but for some reason you have to return back to C, and then again you move back to this B. So although what the change in your position, you have changed your position from A to B only, but what is the distance that you have covered? So distance is AB plus BC plus CB. Means in distance we count each and every step of yours that you have take to reach at the final destination. Got it? But it is not same for displacement. Displacement has some its property different than distance. So we can define displacement. And what a displacement is, you can easily understand then. It is the distance. It is the distance Although I have discussed the meaning of displacement in simple harmonic motion also. So you don't, I think that you have the very conceptual clarity on this topic. What the displacement is. So here it is the distance between, or we can say it is the minimum distance, minimum, that term is important, minimum distance between 2 points, and that point should be initial and final. Okay, so in the same example, if I talk about the distance, distance is A to B, but you need to count these steps also. But let me take a very simple example. Suppose this is the circular track and you are moving on this track also. This is the circular track. You have started from A and you have reached at this point B, and then you have reached at this diagonally opposite point C. Now if I talk about what is the distance, what is the displacement. Now for the distance you need to count this arc, that is ABC. But for displacement I have told you displacement is nothing but final position minus initial position, and it is a vector quantity also, the quantity which has direction, and the quantity which do not have any direction is scalar quantity. Okay, so scalar quantity, all the quantities that has only magnitude not direction is count in scalar, and the quantity that has direction as well as the magnitude which is counted as vector quantities. Okay, so suppose force, if I talk about force, what is that? Is this a scalar quantity or a vector quantity? And do not answer in terms of learning that you have learned. Practically think about it. Can you apply the force without knowing the direction? Any one of you? Is there any chair inside your room, inside your classroom? Although I think it is there. So if I told you the student of JNV Yanam and JNV Ramnagar that push the table or push the chair, then you are going to ask me, na, sir, which table and which chair? So you are finding out the directions. Okay, suppose that particular chair is facing north. So to shift that chair, you need to apply the force in a particular direction. Na? That is how. And that is also you are going to ask me, sir, which direction we have to move this chair. Got it? So that is why the force itself is a vector quantity. Got it? Now, so if I talk about this example, what is the distance in that? If the radius of this circular track is 1 kilometer, what is the distance? Distance calculate kariye. What is the distance? Distance is this arc ABC, and this arc is nothing but the periphery of this circle, semi-periphery, you can say, or semi-circumference, you can say. Okay, this whole circumference is what? 2 pi r, but this is half of the circumference. So distance here is pi into r, and radius is given to you as 1 kilometer. So you can say it, this is pi kilometer or 3.14 kilometer, which is the distance. Now, what about the displacement? So what I have told you, you have to check what is the final position and what is the initial position, and draw a straight line in between them. This is your minimum distance, and it is also defined as displacement. So we have reached at this position C, which is our final position. This is our initial position. So if I draw a straight line This exactly matches the diameter of this circle. So this diameter of the circle is what? Diameter of the circle is displacement here. So displacement is 2 kilometer. Very good, student. You have answered it. Very good. Very good. So JNV Ramnagar is saying that answer is 2 kilometer. Very good. So JNV Yanam student also agree with that. Okay, no offense in that question. So this is distance and displacement. For distance, you need to calculate the actual path. What is the actual path that is being traveled? And for displacement, what is the minimum distance? Okay, that is the only hack. The distance is a scalar quantity, displacement is a vector quantity. Okay. Okay. What is a vector quantity? In which we need direction also. So to draw a straight line, you need the direction, na? Or you can draw this as a straight line. No, you need to draw the straight line in this particular direction, A to C. That is why displacement is a vector quantity. Got it? Now, what if, I'll start with a question. What if the distance is changed with time? Okay. This can be the question. And this was a question for the physicist. What do we say when a distance is changing with respect to time? And one of the student of that time suggested that we cannot deal with this in that same manner, that distance with respect to time, distance per unit time. We need to name it, and that name is speed. Very good, JNVNM student. Very good. So speed is nothing but change of distance. That is important. Distance with respect to time. Okay. So all our vehicle is doing what? They are changing the position, and the change of position is nothing but the distance covered. So they are changing their distance per unit time, which is they are speeding. That we say, na? And if any person is changing their distance with respect to time so fast, so we will say that, what do we say? We say that person is over speeding. Okay. It has a speed more than required. So the police got a challan to this person, and he or she would bear it. So you do not overspeed. Okay. And you must not. Now, what is speed? Speed is change of distance with respect to time, and we denote it with small v. And this is a scalar quantity. Have you ever heard about your mama and papa who is taking care of your driving? I think they used to drive or ride a bicycle or a motorbike or a car for you. So, has they ever told you that we have traveling with 100 kilometer per second, 100 kilometer per hour in north direction? Yeah, they have said it some of the time. Okay. And if they are not saying it, you open the Google Map app, that particular lady in that Google Map will told you that in which direction you are moving, with what speed. So speed is only the measurement of change of distance with respect to time. But what if I add the direction with it? What does it become? It becomes the velocity. Simple. Okay. So we can say that velocity is the change of what? Change of displacement with respect to time. Okay, and this is a what? Vector quantity. Vector quantity. Got it? Now, so this is it. We can write this thing to be like this. Speed is equals to what? Distance, or we will say change of distance per unit change of, or we will say time taken. Time taken. The same way we are defining the velocity also. Velocity is also change of displacement divided by time taken to change that. Okay. So what if I said to you that speed is constant, which means, what does this means? If speed is constant, speed constant means, let's say for example, speed is 10 meter per second and it is not changing. So in each and every second, for first second, the distance covered by the object is 10 meter. In the second second, it is 20 meter per second. In third, 30 meter per second. Sorry, the distance covered is 30 meter. Speed is 10 meter per second. In fourth second, it is 40 meter and the speed is same, which means in each and every second, the distance traveled by this particular object or this particular whatever it is same. You can see it. Okay. So we can say that this particular speed is not changing with time. So speed is constant in this case. Speed is constant. And when the speed is constant, we define the motion as what? We have left behind it, na? What do we call that motion? That motion is termed as uniform motion. So for uniform motion, speed or velocity is constant. Okay. We can say that any change in speed is zero. Got it? And that particular motion in which speed of the system, speed of the car, speed of the person, whatever you have chosen is constant, then that particular motion is uniform motion. In the same way, now you can guess what is non-uniform motion is when the speed is not constant. So we can say that speed or velocity slash velocity also is not constant. Okay, so we can say that velocity here is not constant or speed is not constant also. Now, few fact about this distance and displacement. First is you will remember that the distance is always greater than or equals to the displacement. Okay. Second thing, distance can never be zero. If you have taken one step, that will also count. If you are moving with micrometer also, that will also count as a distance. So distance, if you have traveled, distance can never be zero. Okay. No matter you have traveled for microsecond, nanosecond, picosecond, so much less than a second. But if you have traveled, you have covered some distance. So we can say distance can never be zero if you have moved. Okay? Or specifically, you will say that distance can never be a negative quantity. Can never be negative. But displacement can. Third thing I want to write, that displacement can be positive, negative, and zero. And zero. Got it? For example, if you have started your journey from point A and you are moving in a straight line, you have got to point B and then you again come back to C. The distance between A to C is 10 kilometer and C to B is also 20 kilometer. Now, what is the distance traveled by the object? First, it has moved to A to B, then it's come back to point C. What is the distance traveled? If I calculate, so distance traveled is what? A to B, 10 plus 20, plus it has moved back to B to C, which means it again covered the 20 kilometer additionally. So you can say it is 50 kilometer. This is distance. If you talk about the displacement, I will calculate it for you, then I will give you a question. The displacement here is what? What is the initial point of journey? From where it has started? It has started from point A and finally reaches to the point C. So when it started, we know that displacement is nothing but position final minus position initial. So final position is C and initial position is A. So what is the distance between A and C? The minimum distance, because it has moved in a straight line. So we do not need to draw the extra straight line also. So this is the minimum distance between them. What is that? A to C. So it is 10 kilometer. Got it? Because A it has 0 and then you move to C, so it is at 10. So the distance between final position and initial position, and that is not a simple distance, it is the minimum distance, is 10 kilometer. Got it? So look how the difference changes, distance and displacement. Now, if I talk about that this particular object has now shifted its position to this point D, which overlaps with A, which means it goes to A to B, move back to C, and then move back to A itself. Now, what is the distance in the second case? Tell me, all of you. Tell me. It's 60. Yeah, very good JNVNM student. You're doing great, actually. What about you, JNV Ramnagar student? You are going to tell me the displacement. What is the displacement? Tell me. Okay, this is also JNVNM student has, I think they will told. Yeah, exactly. So what is happening with you, JNV Ramnagar student? This internet is not working well, I think. Okay. Is this the problem? The hip hip hooray. Yeah. JNV Yanam student has answered it well. It is 0 kilometer because the final and initial position is same. So there is no movement, No movement means no distance covered, no minimum distance, which means 0 kilometer. Okay. Now, and remember these facts. This is very important. This is very important. Okay. Now, yeah, we have 10 minutes more. Okay. So speed and velocity I have covered. In that case, we will deal with instantaneous speed and velocity, and we will understand it by a story. Okay. So suppose you got a chance to travel with your friend, but not so far from your house to the market. Okay. You and your friend wear the helmet and travels to that particular market. That market is about 20 kilometers from your house. So we will also draw that. Just a second. The scooter is not up to mark, but yet it is very powerful. And it has arrangement for two to sit. Okay. I have just engineered it. So here you are sitting at this position, and here it is your friend. Okay. And you got a chance to move. And you have started your journey from your house, that is point A. Okay. And here is the point B, which is market. Okay. Now, when you reach to the market, अब ऐसा तो नहीं होगा कि in the entire market you are traveling with a speed of 60 kilometer per hour. No. And ऐसा भी नहीं हुआ होगा, it is not to be happened that from your house to the market you are moving through the same speed. That is not also going to happen. And especially with you, when you have the chance to accelerate it, you will give the full throttle. And when you suddenly saw that a vehicle is coming in front of you, apply the brake suddenly. Okay. So there is a change in the speed all the time, A to B, house to market. And the same scenario happened to the market to your home. Now, I'm standing at your home in front of your door. You are just trying to knock at your house, but I'll just interrupt you and I ask you, what is the speed of yours? What speed you are traveling with? What is your speed? So you are too confused with that. What to tell? I have given a full throttle at the beginning from my house to the main road. I'm at 100 kilometer per hour. Should I tell the sir? They will get angry on me. No, it's not the matter of got angry. Although I will get angry if you are speeding, over speeding the town. But here the fact is there is no single velocity that you can convey to me. Is this the case now? There is no single speed that you can tell me. Sir, we are moving with this particular speed for all the time. No, no one can do. Even I also. But as a physicist or as a physics teacher, I have found out the way how to tell us a particular speed that matches my speed during the entire journey. So what I do, I have measured the time from my house to the market and market to my house. I'm talking about speed, not displacement or not velocity. So I measured the time. Okay. So 2 hours I have spent in this total journey. And what is the distance? Anyone remember? I have told you. What is the distance from your house to the market? Anyone? Let's see who is going to pay, who is paying attention to the class and all. So I have told you that 20 kilometers is the distance between your house to the market. Okay. Got it? So 20 kilometers is the distance divided by the time that you have taken. So you got a velocity that is the average of all the velocities that you are moving with. Okay, so that particular velocity you are going to tell me, or that particular speed you are going to tell me, this is the average speed or average velocity that we are moving with. And that is also relatable, because if I take the distance, take divided with the time that you have taken, it is coming out. So we can assume that ideally you are moving with that particular speed for all the time. Although you are changing your speed, but that is conquered by this average speed itself. Got it? So suppose if I take a graph to draw it, let's say this is your speed and this is the time we have taken. So at particular time your speed is too low. I'm drawing it by this bars, and particular time the speed is too high, then it is too low, then it is medium, then it is too high, then it is very high, very low. So this is the variation of your speed. If I connect this is the variation. What we are going to do, we will take the average of that and draw a simple line that will satisfy all our needs. And that line is of average speed line. Got it? But what if I tell you, and you are a very good student, you take the note of all the things that I am telling you. So during your journey from your house to the market and again from market to the house, you have taken notes at every point of time, that at particular time what is my speed. Suppose you have moved from your house at 9 a.m. and you traveled back at 11 a.m. 2 hours you have taken. Okay. So at particular instant of time, you have noticed that this is my speed. So if I ask you, what is your speed at 9:30? So I'm asking the speed for a particular instant of time. So that is why that particular speed or velocity is termed as the instantaneous speed at that particular instant. Okay. So the speed which is you are telling anyone for a particular instant of time, that speed or that particular velocity is termed as instantaneous speed. But if you are telling the average of all, if you are talking about the entire journey of yours and telling a single velocity or single speed, that particular speed is average speed. Got it? So I will define it for you. I have you enjoyed your story, you every one of you. So any kind of doubt in this instantaneous speed and velocity? So instantaneous speed at specific or particular instant of time, or we can say speed at, for example, speed at 4 second, 5 second, 9:30 a.m., 2:50 p.m. So these particular instant pay, whatever the speed you will tell, that speed is instantaneous speed. Got it? And same for the velocity. For velocity, you will change it with the velocity at particular instant of time, and that is the same thing. Okay? And if I talk about the average velocity and all, average speed and velocity. So average speed I have already discussed with you. What is that? Average speed, you can tell it is the equals to total distance divided by, or we will say total distance covered divided by total time taken. Okay. And for the average velocity, this is for average speed and this is for average velocity. Average velocity, what should be the formula? Total displacement covered, or total displacement, let's say, and total time taken. Okay. So this is it. So we will keep it here. We will keep till here. And rest of this topic we will discuss in the next class. I hope you have enjoyed this session. Thank you so much for being attentive. Any kind of doubt you have, you can ask. Otherwise, you can leave the session. The session is over. Thank you so much. Any kind of doubt, if you have, you can ask. Okay. Okay. Take care of yourself. Bye-bye.